In this video, I'm going to walk you through inscribed and circumscribed polygons and circles. So to begin, we're going to talk about what the word inscribed means. So to inscribe means that a polygon has its vertices lying on a circle. So here I draw a circle for you, and of course there's its center. So I would draw a polygon whose vertices line the circle. So there would be 1, 2, 3, and 4. We'll just do a quadrilateral. Notice that they don't have to be anywhere in particular. So we just connect those vertices, and we have a quadrilateral that is what we call inscribed within a circle. So circumscribed is pretty similar to what inscribed means, except it's mainly talking about the circle being on the inside of a polygon instead. So to understand circumscribed a little bit better, please go back up to the picture that we just talked about. Notice that it's the polygon that's inside the circle, okay? So when we talk about circumscribed, sorry, I cannot say that word right today, we're talking about the circle being on the inside instead. So if I were to go ahead and draw a circle like this, if I had a polygon circumscribed around it, the polygon would be on the outside of this circle. So I would have to very carefully draw a polygon that just touches the circle on the outside. Oop, that didn't do it. This is a little bit more challenging than the one before, but that's really the only difference. So a circle could, the polygon could also be inside the circle too, but we're really just looking that something is being formed around something else, whether that be the circle or the polygon itself. So we're going to take a look at some examples to really clear this up. So moving on to our first example, we have a square with side length of 9 inches is inscribed in circle J. In other words, the square is inside the circle. We are supposed to find the circumference of circle J in terms of pi. So we're going to have to really think about this carefully, because the length of this square, all the lengths of the square are all going to be congruent. So if this side is 9, we can go ahead and label all of them 9. But I also know that those lengths would be considered chords in a circle, and chords have nothing to do with diameter, radius, circumference, etc. So we really have to kind of go about this in a different way. And the way that I see that is by going into what I know about a square a little bit farther. What else do we know about a square besides the sides being all the same? Well, I know that they all have right angles, so that could be helpful. And I also know that if I look at this a little bit more carefully, I also have a right triangle. And that's going to be our key to this problem. I know 2 sides of that right triangle, and I need the longest one, the hypotenuse, to give me my diameter. And of course, the way to find the missing side of a right triangle is to use Pythagorean theorem. So we're going to bring that over. So a squared plus b squared equals c squared. And our a and b are the legs, which are both 9. And I would recommend that you change the letter C to something else, because you could miss or confuse C for being the circumference when you're finished. So use an X, use a D, whatever that you'd like, but I would not use C. I'm going to go ahead and use D, because that's what I'm looking for. That long side, the hypotenuse, would actually represent the diameter of the circle. And if you're unsure about the hypotenuse, you find the right angle, you look at the side across from it, that's the hypotenuse. So we're going to start breaking this down. We've got 81 plus 81, which is 162. To cancel something being squared, we square root it. And we are going to break this down. So 162 is the product of 81 and 2, and I'm picking those 2 values because I know the square root of 81 off the top of my head, which is just 9. So we replace that with 9, And we have a nice simplified version. And this is our diameter. So we're going to say it's 9√2 inches. Now, are we done with the problem? Absolutely not. We have not found the circumference yet, but this part's going to be simple. So we are going to use the circumference formula that contains the diameter, since that's what we know. So we're going to replace our D with 9√2, and since we also have to leave our answer in terms of pi, we're really not going to calculate anything, but we're just going to rewrite this so that it's written properly. So again, the whole numbers that I see, or the whole notation pieces, is the pi and the 9. And the one that gets written first is the 9. So we will write it as 9 pi. And then if you ever have a root, it's always written last, like so. So we just need to add the unit, and that is how you write your answer in terms of pi, like this. So we would say that our circumference is 9 pi√2 inches. Is that very useful in our day-to-day life? Not particularly. It would be more appropriate to work that out, but for a lot of different mathematics, this is the easier way to write it. Let's take a look at another one. Okay, so one more example. We now have an inscribed right triangle with legs 7 meters long and 3 meters long. And again, we're supposed to find the circumference in terms of pi. So I'm going to label what I know inside my picture. I know that the short leg is 3 meters right here, and the longer leg is 7 meters. I also know that this is a right triangle, so there's a right angle. And to get the circumference, I'm going to either have to find the radius or the diameter. And in this picture, it looks like I'm going to be able to find the diameter, since that is the exact same thing as the hypotenuse of this right triangle. So the hypotenuse is opposite the right angle. It's right there. So we are again going to pull down the Pythagorean theorem. And we're going to replace the legs with what I know. So A is typically the smaller leg, B is the next smallest, and I'm going to replace C with a D instead, so I do not confuse it with it being my circumference. So we've got 3 squared, which is 9, 7 squared, which is 49, equals D squared. And the sum of these two values is going to be 58. And from here we square root both sides. And now we're going to simplify. And unfortunately, the only two factors of 58 besides 1 and 58 is 2 and 29. And what I know about 2 and 29, they are both prime numbers, and therefore we cannot simplify either one of these. So we are simply going to leave our diameter as root 58 with our unit of measure, meters, and that's going to be our diameter. So we're going to take this and build our circumference from that. And again, we're going to use the formula with the diameter, since that's what we have. So we're going to do pi times root 58. And there's no rearranging of numbers here. Pi needs to be written before the root, and always the root goes last anyways. So we'll do that. Add our unit at the end, and our circumference is pi root 58 meters. And that will conclude this tutorial.